In today's video, we are going to talk about a process called completing the square. We're going to use this process throughout this unit. Before we get into this new process of completing the square, we're going to look back on factoring. So if I give you a trinomial, our x squared, our x, and our number, and I ask you to factor that, when we factor, we're looking for two numbers that are going to multiply the outside and add to the middle. So if I'm looking for two numbers that multiply to 25 and add to 10, well, two numbers that multiply to 25 are 5 and 5, and 5 and 5 also add to 10. So I have the same number, x plus 5 and x plus 5. Since those are the same binomials, binomial meaning there's two pieces, I can write this as x plus 5 quantity squared. Now this is a perfect square trinomial. Not this, but this. This is a perfect square trinomial. Now it's a perfect square trinomial because when I factor it, I get that same number twice. So it's not like it's 7 and 5 or 3 and 5. I get a positive 5 and a positive 5. I don't have one positive and one negative. So this is a perfect square trinomial. When it factors, we're going to get that same number twice. So if I were to give you an expression, x squared plus 10x, and the third piece is missing, so I have the x squared, the x value. If I'm missing just that number, what is the missing value that would make it a perfect square trinomial? Well, we have this exact same one above, so we know that it's going to be 25, but we're going to work on finding that C value, that missing number that makes it a perfect square trinomial. Once we end up solving all of this and finding this missing value, that's called completing the square. So we are completing that perfect square trinomial. So if I look at this one, I've got x squared plus 12x. I'm trying to find out what value is going to make this a perfect square trinomial. Again, I need to multiply to the outside and add to the middle. So if it's the same number multiplied by itself, that means it's the same number that I have to add itself. So what number can I add to itself to get 12? So the same number that I add 2 times to get 12 is 6. And if I were to square 6, that's going to give me 36. Another way to do that without thinking about it, you take half the middle term, 12 divided by 2, which is 6. You square 6, and that's going to give you your C value. That's always going to work. All right, so that's completing the square. That's finding that third piece to finish off that perfect square trinomial. We're going to use the completing the square to rewrite our equation from standard form into vertex or graphing form. So when we do this, again, completing the square, we see an x squared and we see a 4x. So my job is to complete the square. I'm going to ignore everything else that's going on. So I'm just setting this up, what we did above. I want to use the x squared, the x, and I want to complete that square. I want to make it a perfect square trinomial. I'm not going to attend to the negative one right now. I'm just working on completing that perfect square trinomial. Now, if I were to add a number here, it would throw my equation off balance because I know whatever I do to one side, I have to do the other side. So to properly set this up for completing the square, I know I'm going to add a number to both sides. So I'm going to make a spot on both sides for me to add that number. And by making this spot and setting up that initial piece, it's going to help prevent you from making mistakes. So to complete this square, we take half the middle term. Half of 4 is 2. We square 2, and that's 4. So if I'm adding 4 here, I'm adding 4 there. Now, the first thing that we did today was factor. And the next step is going to be factor. So I'm going to multiply the outside and add to the middle. I'm looking for two numbers that multiply to 4 and add to 4. Yes, the numbers are 2 and 2. So we've got y plus 4 equals x plus 2 times x plus 2 minus 1. So from these two steps, all I did was factor my perfect square trinomial. Now I'm going to rewrite those two binomials. Since it's the same binomial, I can do x plus 2 quantity squared minus 1. I'm almost in graphing form. Just need to get that y by itself, so I move that 4 over. We get y equals x plus 2 quantity squared minus 5. And there is the equation of our parabola, our quadratic. Now, if you remember, if I'm looking at vertex form, graphing form, my x coordinate's -2 because it's inside, it's the opposite, and my y value is -5. So the vertex of this parabola is -2, -5. All right, we have one more. Now I'm looking at number 2. I want to complete the square. We always complete the square with the x squared in the x term. Nothing else is involved in this process. Now this one's a little bit different. Notice that there's a 2 with the x squared. I cannot factor, or I cannot create this perfect square trinomial with that number out front, so I've got to pull it out. And I know that I'm going to end up adding a number to both sides. So I'm going to make a spot here. I'm pulling the 2 out of here. That leaves us with a 1x squared. I pull the 2 from the -12. That's going to give us a -6x plus that number that I'm going to use to complete the square, and that plus 22 is out front. Notice that I did not take the 2 from the 22. The 2 is just taken from the 2 and the 12 because the parentheses are only attached to those two pieces with that third unknown piece of completing the square. So make sure that you don't divide the 2 from all the pieces. You're only taking the 2 from the x squared and the x. To complete the square, we take half that middle term, which is a -3. We square it. That's a +9. Yes, if we add 9 to the right, we have to add 9 to the left. But I didn't just add 9 over here. I added 2 of those 9. So on the left-hand side, we have to add 2 times 9. So we've got y plus 18 is equal to, when we go to our factoring step, remember we're looking for two numbers that multiply the outside and add to the middle. That's a -3 and a -3. Now that we have those two binomials that are the same, I can rewrite that as x minus 3 quantity squared. Last step is to move that 18 over, giving us y equals 2 parentheses x minus 3 quantity squared plus 4. So that's the equation of our parabola in graphing form, giving us our vertex. The x is inside the parentheses, so it's the opposite, becoming a +3. The y is outside, exactly what we see at 4. So the vertex of this parabola is at 3, 4. And that is all for our video today.